Hello everyone, and welcome to our class video about proving lines are parallel. Our learning goal is that you'll be able to prove that lines are parallel based on angle relationships. Just like we had in the last video, I'm going to be referring back to the reference page of postulates and theorems that we glued into our notebook earlier. Okay, again, we're going to be focusing on this part of the postulates and theorems, specifically the part that's on the right. In the previous video, we looked at the postulates and theorems on the left. Now notice that all of the postulates and theorems on the right are listed as converses. If you recall, that means that we switch the part of the sentence that is after the word if with the part that is after the word then. Let's look at it in more detail so you can see. We're going to compare the corresponding angle postulate with its converse. Okay. The corresponding angle postulate says that if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So, what is known in the situation is that parallel lines are cut by a transversal. That is, we have a situation like this, with the lines parallel. If we know that, then the conclusion that we can draw is that the corresponding angles are congruent. Like so. The converse flips the two. In the converse, the corresponding angles are given as congruent. Notice it says, if two lines in a plane are cut by a transversal so that the corresponding angles are congruent. So we already know the corresponding angles are congruent. Like that. The conclusion that we can then draw is that then the lines are parallel. Like so. Okay? So it's flipped backwards of what is known and what conclusion we draw. So the postulates and theorems on the left are used to prove that angles are congruent. Okay? The conclusion we come to is that corresponding angles are congruent if the lines are parallel. The converses are used to prove that the lines are parallel, based on the fact if the corresponding angles are congruent or whichever other relationship we're talking about. Let's see what it looks like to actually use them. Okay, so here is our first example of a proof. We're given that angle 1 and angle 2 are supplementary, and we want to prove that line M is parallel to line N. You guys probably know by now that the first line of the proof is the given information. As we go through this proof, I want to highlight a specific strategy that you can use. I'll say strategy number 1, and this is starting from the end. You ask yourself, what could I show that would let me make the conclusion that's supposed to come at the end of the proof? This is similar to the problem-solving strategy working backwards. This is a strategy, by the way, that's not specific just to a kind of proof, but something that you can use in general for any kind of proof. Okay, so let's look at where we need to get in the end. We need to prove that line M is parallel to line N. Okay, angles 1 and 3 have a special relationship between lines M and N. They're same side interior angles. So if I look at the list of postulates and theorems, I find the converse of the same side interior angle theorem. If two lines in a plane are cut by a transversal so that a pair of same side interior angles is supplementary, then the lines are parallel. Okay, so I can put at the end of the proof, if I know that the angle 1 and angle 3 are supplementary, then that could lead me to my end goal of M being parallel to N. I'm not going to number these statements yet because I don't know how many steps are going to need to be in between, but I've crafted the end part of my proof. If I can show that angle 1 and angle 3 are supplementary, then M being parallel to N would be my next statement. Okay, and the reason I know for the last statement would be this converse of the same side interior angle theorem. Okay, so now we've got to figure out how to get there. How can I show that angle 1 and angle 3 are supplementary? Well, I already know that angle 1 and angle 2 are supplementary. And, I know that angle 2 and angle 3 are congruent. If angle 2 and angle 3 are congruent, then if 1 and 2 are supplementary, then 1 and 3 need to be supplementary as well, because 2 is the same as 3. Okay, why is it that angle 2 is congruent to angle 3? Well, they're vertical angles. So the reason is the vertical angle theorem, which says that vertical angles are congruent. Okay, then that gives me enough information to say that angle 1 and angle 3 are supplementary. Specifically because I can substitute angle 3 for angle 2 in that first statement. Because 2 and 3 have the same measure, if 1 and 2 are supplementary, then 1 and 3 must be supplementary as well. So my reason for that step would be substitution. Because everything flows in the proof now, from one step to the next, I can go ahead and add the rest of my numbers, since I know how many steps there's going to be. So, to recap, what we recognized was that, if I can show that angle 1 and angle 3 are supplementary, then I could come to my conclusion, and we figured out how to get there. Okay, let's look at one more example. I'll go ahead and fill in the given information. Here we're given that lines A and B are parallel, and that angle 1 and angle 3 are congruent. We're trying to prove that the other set of lines are parallel. In this proof, I want to highlight a different strategy. You can ask yourself, what conclusions can I draw from what I already have? If the last strategy was called working backwards, this strategy would be called working forwards. So sometimes you may not know exactly how to get to your end goal, but if you start coming up with some conclusions you can get from what you do have, you might come to a aha moment where you can see, oh, that's how I'm supposed to get to the end. So you're just kind of shooting a few arrows in the dark, if you will, until you hit on something like, there's my pathway to get there. Alright, so let's walk through it. I'm going to go ahead and draw the given information on the picture. I know that lines A and B are parallel, so I'll add the two little arrows. And I'll also go ahead and mark that 1 and 3 are congruent. Okay, so now I need to think, what conclusions can I draw from the information I already have? Well, the information I already have is that lines A and B are parallel. Okay, what angles have a relationship along lines A and B? Well, that would be angle 1 and angle 2. What kind of angles are angle 1 and angle 2? They're alternate interior. And because they're alternate interior, I can conclude that angle 1 and angle 2 are congruent, with my reason being the alternate interior angle theorem. Notice this is not the converse because I used it to prove that two angles were congruent. The converse would have proved two lines to be parallel. Okay, so I used the fact that I already knew that A and B were parallel to say that 1 and 2 were congruent. Where can I go from here? Well, I notice that because angle 1 and angle 3 are congruent, and angle 1 and angle 2 are congruent, well, all of them must be congruent. So angle 2 and 3 are congruent to each other as well. What's the reason for this? Some of you might be tempted to say the corresponding angle postulate, because angle 2 and angle 3 are indeed corresponding. But you can't say that. That's because lines C and D haven't been proven parallel yet. The corresponding angle postulate would require that we know that lines C and D are parallel, because that would be part of the if part of the statement. Okay, the correct way to show that angle 2 is congruent to angle 3 is because angle 1 and 2 are congruent, so I can substitute angle 1 with angle 2. Okay, that's similar to what I just said about, well, if 1 and 3 are congruent and 1 or 2 are congruent, then, well, heck, they're all congruent. Okay, so now that I've shown that angle 2 and angle 3 are congruent, now I have enough information to show that lines C and D are indeed parallel. This is because of the converse of the corresponding angle postulate. It says that if the corresponding angles are congruent, then I can know the lines are parallel. So I can say that C is parallel to D because of the converse of the corresponding angle postulate. Okay, so this strategy I worked forwards, okay, by figuring out, okay, well, given what I have, what can I do from there? And then the rest of the proof kind of fell into place as I kept generating ideas. Now, I want you to take note that the two strategies that I showed you are not specific to a certain kind of proof. Okay? They're just general strategies you can use on any proof. Try either working forwards, figuring out what you can, or work backwards, seeing what is it going to take to show the final results. Okay? You'll get more practice as we go. But for now, that's it. I'll see you later.